This video is over section 3.5, solving quadratic equations by using the square root property. To start off, the square root property is given a real number k. If x squared equals k, then x equals the square root of k or the negative square root of k. So I'm going to highlight that. That's probably the most important thing. This can be more concisely written as plus or minus the square root of k, so this plus or minus sign is just a shorthand. Read as x equals plus or minus the square root of k. And so the solution set would be the set brackets over plus or minus square root k. All right, for this first section, it says solve using the square root property. And zoom in on this first one. Before we do the squared, we need to get a by itself, so I'm going to divide by 49. Here I could get a decimal, but I am going to leave it as a fraction. You will see in a second. So I've got a squared equals 25 over 49. Now to cancel out that square root, or squared, the inverse of that would be square root. So I would square root both sides to cancel out that squared. And so I'm left with a equals, and remember when you square root something from the square root property, we're going to have two answers, plus or minus the square root of 25 over 49. Note here that 25 over 49, they both square root, so the answer here would be plus or minus 5/7. And so you could write that in set notation as negative 5/7, 5/7, or you could just write it plus or minus 5/7 as shorthand. All right, for this next one, we are going to subtract 96 from both sides. And we are left with 6x squared equals negative 96. Then we are going to divide by 6. So we're left with x squared equals negative 16. To get rid of that squared again, we are going to square root by the square root property. We have x equals plus or minus the square root of negative 16. And thinking back to square rooting a negative, that implies we're going to have an imaginary number. And so here, my solution would be x equals plus or minus the square root of 16 is 4, and that negative makes it a 4i. So our solution set for this one would be plus or minus 4i. All right, last one, we want to take care of the squared first because that t is in there with the, that 3 is in there with the t. So if I square root both sides, I'm going to have t minus 3 is equal to plus or minus the square root of 27. Before I continue on, I do want to note that this is the same thing as 9 times 3. So I have t minus 3 is equal to plus or minus the square root of 9 here. Comes out pretty, which is 3, so plus or minus 3, square root, and then there's going to be a 3 left inside. Awesome. So to get rid of that final 3, we're going to add 3 to both sides. It is tempting to combine these two to make 6, but notice here this has a square root 3 on it, whereas the other one doesn't, so they actually do not go together. And the best way to write that would be to put this 3 that's standing alone in front, and then do plus or minus 3 square root 3 off by itself. So just to be quick, I'm going to go ahead and just add brackets here to denote our solution, or solutions too. All right, so the next section says determine the value of n that makes the polynomials a perfect square trinomial, then factor. So it is a perfect square trinomial if you can rewrite it as a factor squared. And so to do this, we take x, we're going to divide by 2 when we come down. So this would be divided by 2. So that would be plus 8. And then to get back up here, we're going to square 8. So for this one, n would be 64. So that is kind of rushed, but basically all we are doing, I'll grab a different color, we are saying that x squared plus 16x plus 64 is a perfect square because x plus 8 squared will give us x squared plus 16x plus 64. And the little trick to get that would be divide by 2 and then take that number and then square it. All right, so let's look at this next one. We have y, so we know it's going to be parentheses squared, y. To get our missing blank from here to here, we're going to divide by 2. So that would be minus 9. And then to go back up here, we are going to do 9 squared, so that would be 81. So for this one, n is 81. And again, off to that side, all that means is that y squared minus 18y plus 81 is the same thing as y minus 9 squared, so a perfect square. All right, following that same pattern, we are going to have parentheses squared, and we're going to have an a this time. When I divide by 2, I can do decimals, but in the future, fractions just simplify things a little bit. If I divide by 2, it's literally 17 divided by 2. And then if I square it, if you think about squaring a fraction, it's basically you multiply the top times the top, the bottom times the bottom. So that would be 289 over 4. So that is n. And again, in a different color, all that means is a squared minus 17a plus 289 over 4 is a perfect square because it can be written as a over 17 over 2 squared. All right, last one is already a fraction, so it's a little weird. We're going to have w, and then to go down, we're going to divide this by 2, and we're going to get 4/3. I went kind of fast, but 8/3 divided by 2 would be 4/3. To go back up here, we're going to square 4/3, so n equals 4/3 squared, so that would be 16 over 9. So that's n. But just so you can see what we're doing again, all that means is w squared minus 8/3 w plus 16 over 9 is a perfect square because it can be written as w minus 4/3 squared. I forgot to write the squared over here. Awesome, so we're going to take what we learned in this section here and apply it to actually solving a problem. So it says solve the problem by completing the square and applying the square root property. So for this one, we need to make these first two terms into a perfect square. So I'm going to write z squared, and we still have this plus 24 equals 0. I'm going to use a different color just so you can see what we're doing here. We're going to divide 8z by 2, so I would get, or 8 by 2, and I get -4. And then when I bring it back up, I'm going to square it. So that would be plus 16. And if I add 16 to one side, I need to add 16 to the other side. So I'm going to put a plus 16 over here. And notice here, I'm going to write this one in blue actually. We don't need to write anything on the left side here because we already made up for it when we wrote the z minus 4 squared. Awesome. So we have z minus 4 squared plus 24 equals 16. We added 16 because we realized when we completed the square, it added an extra 16 on the left. All right, so now we're just going to continue to solve like we did before, minus 24 on both sides. We have z minus 4 squared is equal to -8. We're going to square root both sides, and we have z minus 4 is equal to plus or minus the square root of -8. When we do the square root of -8, we're going to get plus or minus 2i square root 2. I went kind of fast on that. That's a previous lesson. And then last up, I need to add 4 to both sides. And my solution is z equals, notice here, again, these are not like terms because that one has an I and a square root 2 on it. So our final answer would be 4 plus or minus 2i square root 2. And just because I don't want to rewrite it, I'm just going to put little set brackets around it. All right, same thing here. We need to complete the square, so I'm going to group these first two terms. Notice here this one is different than all the other ones we've done because of this 5. So we do need to divide that 5 out before we start. And so when I do that, I'm going to have 5 times x squared plus 4/5 x equals 15. And then now we can go ahead and continue. All right, so we want 5 times something squared. And so to get this, what goes in this blank, we're going to divide by 2. So that would be 2/5 x here. And then when we square it, we would get 4 over 25. So I need to add 4 over 25 to the right side. But notice here, it is multiplied by 5 in front, so we need to multiply this side by 5 as well. So when I add these together, I've got 15 plus 4/5. And I'm just going to leave it like that for now, just to see if it'll cancel out a little bit easier. I'm going to divide by 5. So I'm going to have x plus 2/5 squared is equal to 3 plus 4 over 25. So it didn't really help. That's okay. Let's go ahead and add those together. So I'm going to have x plus 2/5 squared is equal to, if I add those together, that would be 79 over 25. And we're going to square root both sides. And that would leave us with x plus 2/5 is equal to plus or minus the square root of 79 over 25. Luckily, the square root of 25 is 5, so we can make that a little prettier. So we've got x plus 2/5 is equal to plus or minus square root of 79 over just 5. I'm going to subtract 2/5 to both sides. And I've got x is equal to negative 2/5 plus or minus the square root of 79 over 5. I'm just going to throw on the set brackets again. All right, last one, we need to do a little simplifying before we solve. And so let's distribute and get 9x squared minus 9x is equal to 3x minus 12. Let's get our x's together. So I'm going to subtract 3x. And we are going to have 9x squared minus 12x is equal to negative 12. We want to make our left side into a perfect square. But we do need to take care of that 9 first. So I'm going to divide out the 9. So I'm going to have 9 times x squared minus 12 over 9 simplified would be 4/3. And that equals negative 12 still. And then if we want to make that into a perfect square, we're going to have 9 times something squared. And that's going to be 4/3 divided by 2 would be 2/3. When I square it, it becomes plus 4/9. But notice here we are multiplying by this 9 out here as well. All right, so we have 9 times x minus 2/3 squared is equal to negative 12 plus 4/9 times 9, which is just 4, so that would be negative 8. Divide both sides by 9. We have x minus 2/3 squared is equal to negative 8 over 9. We need to square root both sides. And we've got x minus 2/3 is equal to plus or minus the square root of negative 8 over 9, which that can simplify. So I've got x minus 2/3 is equal to plus or minus 2i square root 2 over 3. Again, I'm going fast on that, but there's previous videos on that. And then last step, I'm going to add 2/3 to both sides. And this 2/3 does not have an I or a root 2, so they are not like terms, so I'm just going to keep it separate. So this would be 2/3 plus or minus 2i square root 2 all over 3. I'm going to slap some set brackets around that.